So for this lesson, we will be starting from both vertex and intercept form for the most part. So vertex form is y equals x minus h squared plus k. Remember, h and k both are your vertex. So h is that x coordinate and k is the y coordinate. So then you have intercept form, which is a and then x minus p times x minus q, where p and q are both your x intercepts. So first, we are going to go ahead and write a quadratic function in vertex form whose graph has the given vertex and passes through the given point. So we are going to use vertex form as that skeleton. So we're going to have y equals a times x minus h squared plus k. And then we're going to plug in the things that we know. So our vertex is going to go in for h and k. So we will have, a minus 1 and then a negative 10 go in for k. And then for y and x, we're going to use that point. So we'll have 54 equals, and then we don't have a, but we're going to put in a negative 3 in for x. So now that we have only a, we're going to solve for a by simplifying and then getting a alone. So we'll have 54 equals a, and then negative 3 minus 1 is negative 4, not squared, minus 10. So negative 4 squared is 16. So we have 54 equals 16 times a minus 10. And then we're going to add 10 to each side. And so that gives us 64 equals 16a. And we need to divide by 16. So 4 equals a. So now we can write our whole function because we can go and plug this in for a. So we are going to take y equals, and we're going to have 4 times x minus 1 squared minus 10. So we took out the x and y because these represent any points that actually fall on that parabola. So if we leave them plugged in for, you'll just have two sides that equal each other. And so that actually won't help. All right, so now I want you guys to pause the video and actually, no, I don't want you to. I don't know why that is actually there. Okay, because it shouldn't be there because that is in intercept form. So we are going to use intercept form. So intercept form is y equals a times x minus p times x minus q. So we are going to use intercept form and we're going to plug in what we know. So those intercepts are going to go in for p and q. And then our point is going to go in for x and y. So we are going to have 2 equals, and we don't have anything to go in for a, but we'll be able to solve for it like we did in vertex form. And so then we will have, negative 1 minus p. So we'll do minus a negative 2 for that p. And then we'll use negative 1 again for that x. It'll be minus 3 for q. So then we will just start simplifying to solve for a. So we have negative 1 plus 2. and then a minus 4. So we'll have 2 equals a times 1 times negative 4. So that gives us negative 4a and 2, and then we'll divide by negative 4. And so that gives us a negative 1/2 equals a. Then we will go ahead and take out the x and y and plug in the a term. So we will have y equals negative 1/2, and then x plus 2 and x minus 3 for our quadratic function. So now we're going to look at writing those quadratic functions in vertex form. So when we already have it in standard form. So recall that vertex form of a quadratic function is y equals a times x minus h squared plus k, where h and k is the vertex of the graph of the function. So you can actually convert from standard form to vertex form by completing the square. And so now we are going to complete the square. So we are going to section off that quadratic and linear term. So we're going to have y equals, we're going to have parentheses x squared minus 12x, and I'm going to go ahead and insert that blank that we need to complete the square. But I'm not going to move the 18 this time. What I'm going to do instead is I'm going to subtract that same blank since we are staying on the same side of the equation. And now I'm going to complete the square. So I'm going to take my b, which is negative 12. And so I'm going to take negative 12 and divide it by 2 and square it. So that gives us negative 6 squared, which is 36. So I'm going to add 36 inside the parentheses, but then to keep balance, I am going to subtract 36. So then I'm going to factor that perfect square trinomial, and that is going to give us x minus 6 squared. And so that negative 6 is the x of my vertex. And then 18 minus 36 is negative 18. So then my vertex is going to be 6, negative 18. So let's go ahead and look at example 4 here. We're going to be doing the same thing. And so we are going to take y equals, and we are going to do x squared minus 8x plus something. We're going to put that 18 on the outside, and we're going to subtract whatever we add in from it. So then half of negative 8 is negative 4, which is 16. So we're going to have 16 in both the blanks, and then we will factor. So we have two numbers that multiply to be 16, add up to be negative 8. That is negative 4 and negative 4. So we have x minus 4 squared. And then 18 minus 16 is a positive 2. So in this case, our vertex is 4, 2. All right, so now I want you to go ahead and pause the video and try this on your own for B. Then you can hit play to see how you did. All right, so for B, you should have y equals x squared plus 6x plus something, and then the plus 4 minus something. So we have y equals, and then x plus 3 squared, because we had to add and subtract a 9. And then 4 minus 9 is a negative 5. So then the vertex is negative 3, negative 5. All right, so now let's talk about changing to standard form. A lot of this is just simplifying, because we can take that x minus 2 squared and we can use FOIL. Just remember that you cannot distribute that squared. You have to use FOIL, because that squared means that you're multiplying what's in parentheses times itself. So you're going to have x squared minus 2x plus 4, and then bring down the plus 2. And then you'll combine like terms. So x squared minus 4x. That's not a plus 2, that's a plus 3. And that'll be plus 7. So that will be your equation in standard form. And then on B, we're going to do the same thing. We have that negative. And so we have x plus 3 times x plus 3. I do highly suggest using FOIL before you distribute that negative. There's kind of a pattern that exists there if you haven't noticed, and it makes it a little bit easier to handle. So we just used FOIL to get x squared plus 3x plus 3x plus 9. That gives us x squared plus 6x plus 9, and then minus 3 with the negative on the outside. So then y equals negative x squared minus 6x minus 9 minus 3. And so when I combine those constants, I have negative x squared minus 6x minus 12. And that is my final answer in standard form. So now for our last example, we are going to find the quadratic equation from a graph. So the first thing I would do is find the zeros of the function. Then I'm going to use the zeros in another point on the graph to write the function in factored form. Remember that you'll need to solve for a. Hint, your y-intercept is usually a good point to use because you have a 0 involved that helps get rid of some things. And then we'll simplify using distribution to change to standard form, and then from there we'll complete the square to change to vertex form. So we're actually going to write this in all 3 forms before it's all said and done. So let's go ahead and get started here. So the first thing I'm going to do is identify those zeros. So it looks like I have negative 5, 0. And I have 1, 0. So my y-intercept is 0, 10. I think that's going to be my point that I use to solve for A. And of course, I could also use my vertex. That's also a good point that you could use as well. I'm going to use it mainly just to check myself, because that's going to be negative 2, 18. So I should be able to pull that out of vertex form when I am done. So we are going to plug into intercept form. So I'm going to have y equals a times x minus p times x minus q. And then I am going to go ahead and plug in the points that I know. So I have 10 equals a, and then for my x, I'm going to use 0, and then minus a negative 5, so that becomes plus 5. And then I have, let's see, an 0 minus 1. So that gives me, let's see, 10 equals a times 5 times negative 1. So 10 equals a times, let's see, negative 5a actually. Divide by negative 5. And we get a negative 2 for a. So intercept form is going to be y equals negative 2 times x plus 5 times x minus 1. And so I'm going to use that as my jumping off point for standard form. So I'm going to have y equals negative 2 times x plus 5 times x minus 1. And so I am going to go ahead and FOIL. So I'm going to have the negative 2 stay outside, and then I'll have x squared, and then minus x plus 5x minus 5. And then y equals negative 2 times x squared plus 4x minus 5. And now I'm going to distribute that negative 2. So I have negative 2x squared, see, minus 8x plus 10. Okay, so now what I am going to do is I'm going to go ahead and put this in vertex form. So I'm going to come over here. And I am going to take my standard form, and then I am going to go ahead and separate out some things. So this does have a GCF of negative 2. So I'm going to show you guys a trick to kind of get that out of there. And so what we're going to do is we're going to actually divide both sides by that negative 2. I will have to bring it back over in the end, but it at least gets rid of it for now. So we're going to have y over negative 2 equals x squared plus 4x minus 5. And then I'm going to have to complete the square. So we're going to have y over negative 2 equals x squared plus 4x plus something minus 5 minus something. So half of 4x, or half of 4 is 2, and then squared is 4. So we're going to add and subtract a 4. So when we factor, we'll have y over negative 2 equals x plus 2 squared, and then minus 9. So we're not completely in vertex form yet because we've got to then multiply both sides by that negative 2. And so what this is going to do is this is going to get y back alone again. And then we're going to have negative 2 times x plus 2 squared plus 18, because we have to multiply everything by the negative 2. And then this gets us to our vertex form. And we have a vertex of negative 2, 18, which is what we needed. So we have all three forms for this quadratic equation, and we are officially finished with it.